Hi everyone, and this will be the final video in the 5.3 series of solving trigonometric equations. As we start this problem, notice we're still exclusively on the unit circle, and let's just hop right into it. So again, whatever algebra it takes to isolate your sine or your cosine or your tangent or whatever the case is, in this case it's cosine. This is following a quadratic form. So we are going to factor, and just like we've done a couple of times previously, going to get rid of those cosines temporarily to get rid of the noise, as it were. In this particular instance, we're going to factor to make your 2x squared. You're going to think 2x and x. To make your -1, you're going to make a 1 and a 1. Now we just need to work out the positives and negatives. So we're going to choose +1 and -1 because our combination to make the x's in this case would be -2x and +1x to make that -x happen. And now that we have this thing factored, let's go ahead and insert the cosines back in. So now we have 2 cosine x plus 1, and then 2, no, not 2 cosine x. Cosine x minus 1 equals 0. What comes next? Well, remember, zero product property says that if the product of two things is 0, one or both of those things can be 0. So we take 2 cosine x plus 1 and make it equal to 0. We also take cosine x minus 1 equals 0. And now we solve both branches of this thing to get cosine x equals -1/2. And we get cosine x equals 1. So now we go from our unit circle. We want our 1 here. And our -1/2 would be here and here. So if we're just simply solving on 0 to 2 pi, we've got 0, we've got 2 pi over 3, and we've got 4 pi over 3, and we can write that in our fancy schmancy bracket, curly braces for set notation, and be done with it. But since we're here and since I have a captive audience here, what happens if we extend this rather than (0 to 2 pi? Let's do, let me change the color of this here. Rather than 0 to 2 pi, let's do the interval -infinity to +infinity. In other words, all. Right, so let's do all solutions here. And so what we're going to do is let's graph, let's plot, let's sketch our 3 solutions from earlier. We had 0. We had 0. We had 2 pi over 3, and we had 4 pi over 3. Those are the 3 values on the unit circle that fulfilled the original equations. Now, remember, is there a consistent rotation that can get us from one solution to the next to the next? And so this, is 120 degrees between all of them. We kind of always default to our degree intuition, but 120 degrees, remember, is 2 pi over 3 radians. So what we can say is that all solutions would be 0, right? It'd be 0 plus any multiple of 2 pi over 3, where remember n is an integer. And this is a really nice looking final answer. You don't have to include the 0 plus, because 0 plus is just that thing. So what we've got is all solutions to this thing are just 2n pi over 3, such that n is an element of the set of integers. And I think that is a nice looking answer. In other words, you can plug in anything you want. If you put in any value for n, you will get a cosine that is either negative 1/2 or 1. So if we take cosine of 2, let's just put 1 pi divided by 3. We're either, no matter what this value becomes right here, we're going to get either a negative 1/2 or a 1. So we got 1, we got 2, got 3, got 4, got 5, 6, we got 10,000. It's rounding a little bit. It's doing its calculus to figure that out. So just, again, a learning point there. And again, we'll do plenty more of these in class and see how it goes. So I'll see you then, and hopefully you enjoyed this.